In this video, we're going to go ahead and get started working on making the region servers, or the game servers, communicate with the master server. And so we'll see how far we get with that. So basically, what has to happen here is our region servers are going to have these configuration files for each one of the individual games. Right now, the way the configuration files are set up isn't the most optimal. I'll come up with something better at some point, but at the moment, we're just going to continue as we have been. What we need to do, however, is inside of our config.json, have it point to our master server so that the game servers can register themselves with the master server. And for that to work, we're going to need a couple of things. First, we're going to need a reference to where the master server is for the region server, but we also have to tell the master server from the region server where the region server is, what IP address, what address or domain or whatever, plus what port to connect to it back to. I don't know if those are words, but whatever. So basically, this master configuration file, if you recall, is merged in to all these other configuration files. So what I'm going to do here is I'm going to start off by putting in a new node here. And we are going to create a strongly typed representation of this, of course. But I just want to show you guys what the JSON file is going to look like first. And we're going to have a master server right next to our game server. And inside of master server, we're going to have an address, which in this case, it's simply going to be my localhost, so 127.0.0.1, or localhost, whatever you want. Or if this is a production environment, or if your servers are not in the same physical box, you would obviously put the address of your master server there. We also are going to, well, let's see. I think what I want to do, now that I think about it, we already have this Photon server connection. We haven't used it yet, but it is being referenced from within our API. For when a game starts, the clients need to know what application to join, and right now this has an address and application name, and I think I'm just going to reuse this. So instead of this address just being an address, I'm going to also add in the port, so 5055 for the UDP port, and then I'm going to bring in an application name, and come on, you can do it. And let me go ahead and refresh my memory of what our master server application name is. So I have my Photon server.config open, and our application name is simply Buzz MMO Master. So I'm going to move this off to the side, and we'll use that here. Buzz MMO Master. So I'm putting this in the base configuration file, and it will be merged into our Game 1 debug, Game 1 production, Game 2 debug, and Game 2 production configuration files as well. So we don't need to specify it in 4 places. Now, for the game server, we're going to have a couple parameters here, and I'm going to add in the additional parameters, but I'm not obviously going to fill in these parameters in the base config, but we will override them in the config overrides. So we're going to have a UDP connection, which will be the exact same thing what we had before. We'll have an address, and I'll simply say address, placeholder, and we'll also have an application name, placeholder. And after our UDP connection, I'm also going to do something interesting here. I'm going to do a unique ID, and we'll put a placeholder here. So the unique ID is going to be a GUID that I'm going to assign every single individual game server as a means of knowing, or as a means of identifying itself. It's a unique ID, because we will be storing information about our game servers inside of our database. So we need to be able to reference them by a GUID. And yeah, so now that we have our kind of placeholder here, I'm going to go ahead and open up our Game 1 debug and our Game 2 debug, and let's just do these side by side. Maybe it might be easier to take all this placeholder stuff and copy and paste it right there. Now for the Game 1, the name is going to be just Game Server 1. Again, the name here isn't significant really in any way other than a human readable way to identify the game server. And the address is going to be 127.0.0.1.5055. And then the application name in this case is going to be Buzz MMO Game 1. And again, if you're wondering where I'm getting that from, I'm getting that from my Photon server.config. We have our Buzz MMO Game 1 right there. For the unique ID, I'll go ahead and generate a GUID. So I'm going to come up here to Tools, and I'm going to select Create GUID. And for the format, I'll just use the registry format. That's fine with me. And then I'll just hit New GUID a couple times, whatever. And then hit Copy, hit Paste, and I'm going to take out the curlies. So obviously you'll have a different GUID for your own configuration for this, but that is the game 1 debug JSON. So now let's do our game 2 debug. And for that, I'm going to do the same thing. I'm going to go ahead and copy and paste this. Remember, we're not in the root of the config. We're in the game server of the config. Remember, the game server is a sibling of the master server configuration. But for the game server 2, we're simply going to change 1 to 2 here. And then we're going to change 1 to 2 here. I have another application called BuzzMMO Game 2. And then I'm going to generate another GUID. So I'm going to come down here, create GUID, hit new GUID a couple times, hit copy, hit exit. Hitting new GUID a couple times really affects nothing, but it makes me feel a little bit better. It's like when you copy and paste something, you always hit Control-C at least 3 times. So yeah, that is our configuration. So now with this configuration, we can go ahead and create a class that will represent the information we have here. And we already have one of the classes we need, which is going to be this UDP connection as well as the master server. Or, maybe for the master server, just to be consistent with the game server, I'll also do a UDP connection wrapper around the master server configuration. So now the master server is more consistent, and more importantly, we can now add additional configuration parameters for our master server if we need to. I'm not sure that we ever will, but now we can, now that I've wrapped that around. I just wanted to make that quick change here before we get locked into this particular schema. So now what I want to do is I want to create a class that represents this. And it's going to live, it's actually 2 classes, one for the games, well 3 actually. One for the master server, one for the game server, and then one for this entire file. And they'll each be classes we'll use JSON.NET to deserialize. And I'm going to put 2 of those classes in my BuzzMMO server project. So remember, the BuzzMMO server project is the base project for our master server and our game server. And the configuration that I want to create is we'll do a master server config. And again, this master server config is going to correspond to this element right here in our configuration. So what I'm going to do is I'm simply going to do a public Unity, come on, no, not Unity, Photon, Photon server configuration, and I'm going to call this UDP connection. I'm not sure how it auto-completed that UDP connection there. But regardless, the point is, get private set. Well, let's just do get set. These are just going to be dumb data objects. I'm not concerned about the data integrity. They're not responsible for validation. So that's our master server config. That represents this element. Let's go ahead and do our game server config. So over here, I'm going to create a new class called, well, game server config. The game server config is going to be a little bit more involved. We're going to have a public string name. And again, these properties here correspond to this right here. If we name the properties the same thing in our class, we'll be able to straight up deserialize with JSON.NET without any additional annotation or any additional work. So make sure you get the names right. Then we're going to do a public Photon server Photon server connection UDP connection. Oops, just get set. And then we're going to do a public GUID unique ID. Get set. And that now we have our game server config and our master server config classes, and it's important that they live up here in this BuzzMMO server project so that they're available to both projects underneath it. But now what I want to do is I want to write the master config object for this entire file. And for that, I'm going to place that inside of the project that's going to be loading in this particular config file, and that is going to be BuzzMMO server region. So I'm going to go ahead, I'm going to create a class called config, or am I? Yeah, I'm going to create a class called config. I don't want to create a class called configuration because there's already another class in the .NET framework called configuration, and I really don't want to deal with name collisions. And this class is going to represent this entire file. So we're going to start off with a public master server config, master server. Remember to get the name as the exact name you have in the JSON file. And then public game server config, game server. So that is our master config object that our BuzzMMO server region is going to be loading in. I don't think I actually said why I really wanted master server config and game server config to both be in the root project. The reason is the region server is going to be sending the game server config to the master server. And that's how the master server is going to know what address and what application name to connect to a game server, which is then going to relay back to the client so the client knows which game server to connect to. Because remember, when you begin a game, which if you want to take a look at these files one more time, I'm about to close them. So let's go ahead and just close out all of these guys. Because remember, when we start a game, that's going to be started from our game lobby system, and it's going to be begin name, and we are going to get information when the server, or on the client, on game started, we get the Photon server connection server, which represents the game server to connect to. And honestly, maybe we should rename it right here to game server connection, just to make it a little bit more nice. And stop renaming things. Okay. So yeah, so at this point, what we have to do is inside of our region server, we have to connect to the master server. So we're going to do that in our application CS, and we're going to get that information out of our config. Furthermore, right here, our config, we get the game server name out right here and pass it into our global context, which if you recall is part of log4net, allows our log messages to prepend which game server it is. What I'm going to do is I'm going to change things a little bit here. Instead of deserializing it into a J object, which if you recall is just a standard JSON object that's not typed, I'm going to deserialize it into a config. And now, instead of doing config at gameserver.value of string of name, we can simply do config.gameserver.name. So that is awesome. Okay, so we now have our configuration. We can nuke all this stuff. Now what I'm going to do is I am going to go ahead and create a class that we're going to be making heavy use of, and that is going to be our game server context, which actually already exists, and it's right here. Okay, so we already have our game server context. We take in a serializer, but we're also going to take in our configuration as well. So we have our serializer, and then we're going to take in a config object, and we're just going to call it configuration. Or config, whatever, config's fine. And then I'm going to go ahead and introduce an auto property of config. So now we have our game server context, which has a, oops, we can actually just use C#6 feature for that, which just exposes a config for now. We're not going to do a whole lot with the game server context yet, but we will be instantiating it. So let's hop over here and let's instantiate. But what I'm going to be doing here is I don't think I'm going to be doing it here. Do I want to do it in the constructor? Yeah, why not? Let's do it in the constructor. We already have it there in the constructor, but I do have to take this line that creates the configuration object, deserializes it, and I do need to move it from setup into the constructor here of this application. And I, of course, have to add it as the second parameter here. So now that we've done that, we've moved this config deserialization up to the constructor. We do need to change this reference, this property. We now need to do underscore application dot config. Okay. So that is our constructor. Let's go ahead and talk about how we're going to be connecting to the actual server. It's actually pretty straightforward to do. We need to override. I'm going to stub this out. I'll do a private void connect to master server right here. Honestly, we could move this functionality out to its own class, but it's only a couple methods. I'll leave it as is. This is something that we need to write once, so then we can basically forget about it. And then I'm going to override two methods on the actual Photon application base class. There's two methods that we need to worry about when connecting from a Photon server to a Photon server. And that's going to be create server peer and on server connection failed. So let's go ahead and override those two methods. And let's just nuke the calls to base because we won't need that. So these three methods need to be implemented. Connect to master server is going to perform the actual, hey Photon, you need to connect this server. Create server peer is going to be called by Photon when the master server receives our request to connect, accepts it, and does all its magic. And then on server connection failed obviously happens when the connection fails. But this is going to be really simple because we're only connecting to one server. All the game servers connect to the master server. The master server is going to have to deal with multiple connections, but the game servers do not. So it's going to be fairly straightforward. Let's do our connect to master server first. The method that we have to invoke is on the application base class of Photon. And we can say connect to. And you'll notice there's a couple deprecated things that we shouldn't be using, but there's connect to server mux TCP, connect to server TCP, and connect to server UDP, and connect to server WebSocket. So obviously we're going to be connecting to a server UDP. And if we open up its signature here, we see that we need an IP endpoint, an application name, a state, a number of channels, and optionally a MTU, which if you read the documentation on that, it is going to be the maximum transfer unit, specifies the max data size for each UDP package. This is a bunch of stuff that we usually don't have to worry about when making Photon connections because there's a bunch of defaults that Photon will give to you when you connect to basic clients, but this is a slightly lower level API, so we have to fill in this stuff. So we need to go ahead and create an IP endpoint. And to create an IP endpoint, what I'm going to do is I'm going to say var master server address parts equals application config master server UDP connection address split on colon, and that wants a char, not a string. So because the problem is I do believe that the IP endpoint requires us to specify the address and the port separately. Actually, let's go ahead and verify that. I'm going to say var master server endpoint equals new IP endpoint. And we have a long address in port. I wonder if there's any constructors on IP endpoint. No, there's not. So we do need to specify a IP address object and a port number. So that's why I'm splitting it here. And what we can do with that, to create an IP address, we simply do IP address.parse, and we're going to say IP address parse master server address parts at 0. And then for part number, I'm going to say int.parse master server address parts at 1. Really not a big fan of that really long name, so I'm going to call this address parts, and I'm going to call this endpoint. That really long name was irritating me. So as you see, we split it by colon, which if you recall, the way we specified it in our config.json is we did IP address followed by a colon, then followed by the port. So we're not doing any sort of DNS resolution here, which if you wanted to specify it through DNS, you might have to do some different sort of parsing. Also, there is a lot that can go wrong here. Maybe master server is null, maybe UDP connection is null, maybe address is null, maybe it couldn't parse the IP address, maybe it couldn't parse the integer. I think I'm just going to, on this sort of startup thing, I'm not too concerned about catching errors because if it happens, I want there to be an exception because it is a programming error, but this is also a matter of validation. I think I'm just going to do the lazy thing here. I'm going to say IP endpoint, and I'm going to say try on all of this, remove the var, then I'm going to say catch exception E, and then I'm going to throw a new, I don't know, just an invalid operation exception. Throw a new invalid operation exception with cannot parse config master server UDP connection.address, and then pass the inner exception in as E. So it's a sort of shotgun approach to doing validation here, but again, so many things can go wrong. I'm not going to clutter all the code up with a bunch of try parses when we can make a easy to understand error message. Maybe make it even better. Please specify it in IP followed by port format. There we go. A little bit friendlier message. Okay, so now we have our endpoint. So now we need to connect to the server. That's easy to do. We simply do endpoint, comma, and then the application name, which is application.config.masterserver.udp-connection.application-name. State, I'm just going to pass a null. I don't care about state. And number of channels, I'm just going to leave as 1. And then for the MTU, I'm just going to pass a null here, since I do believe, let's go ahead and decompile this real fast. If the MTU is null, what does it do? What does it do if the MTU is null? The MTU is null, it just casts it into an object and passes it. Whatever. I don't care about digging further into this. I assume that it is does accept nulls and will do a default because it is a nullable value type, which was a conscious decision by whoever wrote that API. Now, I did not include connect to server UDP within this try catch block, and the reason I didn't do that was because it's a different operation. If this throws an exception for whatever reason, or if maybe this throws an exception, I want that exception to properly bubble up and not get the added information that I added here. So anyway, that's connecting to the server. This will actually go out and tell Photon, hey, go ahead and connect to another server. And when you're done, invoke create server peer. Now, we've already written a peer before in our server master, what did we call that guy? Just peer. And he inherited from MMO peer base. MMO peer base inherited from peer base and did a bunch of just really straightforward things. The problem is, though, is the master peer is different. So what it wants us to return here is the same concept as a peer, but server peer base, if you go ahead and look into it, is actually something that inherits from the peer base. So unfortunately, we can't reuse we need to create a new peer class that inherits from server peer base, but we only do it on this side. It's important to understand that when this master server gets a connection, it's just going to connect it as a normal peer, as a normal peer like a player would be connected to as. So we don't need to do anything funky on the master server side, but here we do need to create a server peer base class. So I'm not going to worry about creating a base server peer base class like what we did with our base peer base class. And I just said base a lot, but we will just go ahead and just create that outright here in our region server, because that's the only place we'll need it. And not surprisingly, what I'm going to call this class is going to be master server peer. And master server peer will inherit from server peer base. And for the constructor, I'm going to go ahead, because we do need to satisfy a base constructor. I'm going to go ahead and do public master server peer, and he's going to take in an init response. And we'll call this response. He's also going to take in a game server context, which we'll call application. And then we're going to take in a delegate called on disconnect. Or no, I'll do that as an event. Should I do it as an event? An event might... No, I think that'll be fine. I'll do it as an event. So, of course, we do need to satisfy the base and the base constructor, which is simply going to be response.protocol and response.photonpeer. So, again, server peer base has those two things. And now it's telling us that server peer base is abstract. So let's go ahead and implement the missing members, which should look familiar. We have our on operation request, on disconnect, on event, and on operation response. So it looks pretty much exactly like a peer. Except what's interesting about it is it has this on event. So you remember, normal peers, like the one right here, normal server-side peers, only if you look at the thing here, they'll only have a on operation request and on disconnect. There's the only two things that a normal peer to a normal client will have. But a server peer has on operation request, on disconnect, on event, and on operation response. You might notice this as the combination of a client-side peer plus a server-side peer. Whereas a server-side peer only has on event, on operation response, and on disconnect. And a normal peer on... See, this is where things really get confusing. Because we're dealing with three peers now. Three types of peers. We have the client peer. Maybe I should establish some terminology, get my head straight here. We have the client peer. That's a peer that the Unity game thing project is going to use. A normal client peer that will connect to a Photon server. Then we have a server peer, which would be the peer that BuzzMMO Server Master is currently doing, the normal peer class, but this is a server-side client peer, if that makes sense. And then we have a server peer, which is a kind of a combination of both of them, so I'm not sure what terminology I should use to keep things straight. I really should think of a name for this. I'll think of it later. The point is we now have this master server peer, which is a combination of a client peer and a server-side client peer. That's a terrible name for it, but I hope you guys get what I'm saying. Anyway, well, let's go ahead and finish out the constructor here. And also, before we do that, I'm going to add a public event action on disconnect. Oh, come on. On disconnected. There, you happy now? And then I'm going to come over here to this application guy, and I'm just going to hit Alt-Enter, Enter, and that'll alias him out into this nice little private field. Private read-only field, rather. So we have that all going. For the on-disconnect, we will implement that now. Let's see, let's make a log first. A private static read-only ilog, give me a log, log equals log manager get logger. I grabbed the wrong log, didn't I? I grabbed a straight-up log for netlog. I want to use... No. Stop that madness. Whatever, I don't care. We'll just use a straight-up get logger type of master server peer. Okay, so we have a straight-up log for netlog. And then on disconnect, I am going to come down here and say log.info. And I'll say log info. We'll open up a template string and we'll say master server peer disconnect : reason code / reason detail. And then I'm also going to do on disconnected, and I'll do a dot, oops, stop that. I'll do a question mark dot invoke, which is the other way around, isn't it? You can tell I haven't done this a lot. Oh, on disconnected. I had it right the first time. Dot invoke, and then we'll go ahead and just invoke that event, let everyone know that we've disconnected. All right, so that's all we need for now, right here. So take one last look at that code, and then we're going to hop back into the application, and we can fill out our create server peer. Do we have a log here yet? Yes, we do. Okay, so what I'm going to do here is I'm going to say var peer equals new master server peer, passing in our init response and our application. We don't need to worry about the state. Then I'm going to say peer on disconnected, and on disconnected, I think I'm going to leave this as a lambda, but I'm going to leave it blank for now. We'll see why in a second, and then we'll return the peer. Okay, so that's our create server peer. And for our on server connect failed, we can't do that yet, because what I want to do is I want it to continuously try to connect to the master server. So I want it to try to connect to the master server immediately on startup. Then if it failed, I want to schedule a reattempt to connect to the master server, let's say every 2 seconds. And then if it disconnected, I also want to schedule it to reconnect every 2 seconds. And in Photon, what we want to do is we want to take advantage of Photon's fiber systems to schedule those events. I'm not going to use a system timer or anything like that. I'm going to use Photon's actual concurrency platform to do that for us. But that's going to require that I create a fiber, which I haven't done yet. So let's scroll up, and in the constructor, I'm going to create a fiber. So let's see here. Private read-only I fiber, fiber, and we'll just call this, just call it fiber. I don't care. There'll only be one. And then I'll instantiate it here. I'm going to instantiate it before we create the application, because I think at some point we are going to pass this fiber object into the game server context. So I'm going to say fiber equals new. Let's use a thread fiber. And then we'll say fiber.start. All right. So we now have our nice little concurrency thing that we can schedule events on. And with that, we can do a couple things. The first thing I want to do is scroll down into setup, and I want to call connect to master server right here. Then what I want to do is scroll down to on disconnect. On disconnect, basically all that's going to do is say fiber schedule, and we'll schedule on interval. Well, no. We're just going to schedule it. We're going to schedule connect to master server in X amount of seconds, and we'll call this. We'll write a const field for this, and we'll say I don't know, server connect timeout or something like that. And you know what? We can make this one line, can't we? So that looks a little nicer. And we don't have this constant yet, but we will here in a moment. And then on server connection failed, I'm going to say log info, and I'm going to say, I don't know, could not connect to master server. Maybe also it might be cool to pass in this error message, actually do application.config master server UDP connection application name slash. This is going to be ugly. I'm going to alias this out into a local variable. I'm going to say no, I'm not. What am I thinking? We already have a toString on our UDP connection, don't we? Our Photon server connection. We have a toString. We do have a toString. So I can just print that out. So unable to connect to master servers, colon, error code slash error message. And then what I'm going to do is I bet you guys guessed it, fiber.schedule connect to master server, comma, server connect timeout. So I'm not doing a set interval here. I'm saying only have one connection going, or one connection attempt going at a time. But one of two things are going to happen. Either create server peer is going to be invoked, in which case we have a server, or on server connection failed will be invoked, in which case we'll reschedule the connect to master server. So with that, I'm going to scroll up through this code slowly in case we don't return to it. We do need to write that constant, and I like my fields at the top. People who don't like their fields at the top in C# are silly. I'll do a private const int server connect timeout 5,000 for 5 seconds. Now, maybe I do actually on our create server peer, maybe I do want to go ahead and add in the log info connected to master server application config master server UDP connection. And I also might want to change this log info down here to a log error. And with that, let's go ahead and hit build solution, because I don't feel like finding the F6 key right now. And we should see some action in our logs already just by doing this. So that happened. Let's go ahead and come up here. Our master server says bless, so we know he started. And we get one game server connected to master server peer. And this is game server 1. I have a feeling in 5 seconds we'll see game server 2 saying the same thing. But maybe I'm wrong. Okay, maybe not. So let's go ahead and figure out what went wrong there. Let's first go ahead and jump into our deploy folder, and go into game 2, go into bin, and check our dates. Definitely check our dates. So date modified today, all this stuff. Why is there a config empty folder? I don't know why there's a config empty folder. All right, let's open up this config.json file to make sure the config copied over right. The master server is indeed correct. The game server does have the correct name. Everything got merged in properly. But for some reason, it didn't start. Let's go with the nuclear option real fast. I'm going to clear out all of my logs so we don't get confused. I'm going to go ahead and just stop the application. Okay, I didn't clear them out hard enough, apparently. Right-click, default, start as application. So let's wait for the master server. Okay, the master server started, and we got a game server 1 connected to master server. All right, so another way to debug this would be, again, I want to see 2 messages that they connected to master server, not 1. Let's go ahead and on connect to master server, I'm going to say log info connecting to master server : and then pass in application config master server UDP connection. That's so much fun to write. It isn't really. Now I'm going to hit F6, jump back over here, and we see game server 2 did connect this time. So game server 1 connected, then that disconnected, and then game server 2 is now the only one connecting. What? Let's try this one more time. I'm going to go up here. I'm going to change a single line of code and hit F6 to force a rebuild. We should see some action here. Master server peer disconnect for game server 1. Game server 1 connected to master server. Okay, I don't know if I'm blind, but it seems to be working now. I'm not entirely sure what was causing the game server 2 not to print out to the log. Maybe file lock contention. I don't know. But as you can see, we are now connecting. And we also see a bunch of errors in our application server, and that's really, really, really not surprising. What's going on here is null reference exception because I have a very good theory as to why this is happening, but let's go ahead and verify my theory so I'm not a complete, don't look like a complete idiot. Okay, the reason our master server is throwing that exception on disconnect is because remember, this MMO peer base is now being used for both the client and the game servers. So when it connects, it never got a init context request. And because it never got an init context request, it never created the context. And because it never created the context, when it disconnected, the client context was null and on disconnect failed. So if we jump into the implementation here of create context, we see that right now we only detect if the context type is a player. In the next video, what we're going to do is we're going to create a new context type. Right now we just have player. We're going to create a new context type called game server or something like that, so that we can do an initialization request from our game server to our master server saying, hey, I'm a game server. Go ahead and give me a different player or a different peer context. And with that, I guess we'll see you guys in the next video.